Okay, hello, and welcome to our lecture on the Anthropocene. I am sitting on the floor of my living room because someone is, my office is in use right now, but that's okay. You get to see my beautiful Philly fig tree in the back here. All right, so we're going to talk about the Anthropocene today, and we've dealt with all of the other spheres of the Earth system, the biosphere, right, the hydrosphere, the atmosphere, and so now we're going to talk about the anthroposphere. The anthroposphere, of course, being all of the things on Earth, all of the components of the Earth system that have been touched by, corrupted by, influenced by humans. And the anthro really gives it away. So anthro, the Greek prefix here, means like human, right? So the anthroposphere then is the part of the Earth system that is changed by human activity. This is a perfect example. A tropical rainforest on fire. It looks like it's been slashed and burnt, which means that the trees have been leveled, have been chopped down to make room, presumably for a palm oil plantation. This looks like it's in Indonesia. Then they burn the litter that returns the nutrients to the soil, and then you have a fertilized plot of land, which you can then grow a crop. In this case, probably oil palm trees. So this is a good example of the anthroposphere, what the anthroposphere actually sort of means, what the embodiment of the anthroposphere means for our study here. We obviously cannot understand the anthroposphere without understanding humans and where humans have sort of, how many humans there have been on the planet. And so this graph here shows the world population throughout history, the number of people estimated that live on the Earth. And so we can see that around 2 and 3 million years ago, modern anatomical humans did not exist. These were what I would call proto-humans. They were pre-human, Australopithecus, for example, and others. And so for many years, for millions of years, 2 million years, population of these proto-humans and then ultimately modern anatomical humans remained low due to the hunter-gatherer structure of human societies. So around 200,000 years ago or so, modern anatomical humans first appeared on the planet in Africa, in the eastern, what we would call Horn of Africa, or the Great Rift Valley, and they lived there for many, many years. Around 65,000 years ago, modern anatomical humans started to migrate across the globe, traveling to Europe and South Asia and ultimately Australia, and then ultimately North America. About 15,000 years ago, North and South America were finally completely populated by humans, which had made their way out of Africa many thousands of years before that. Around 9 to 10,000 years ago, a major revolution happened among the human population on the planet. And that is in 3 different regions across the globe, entirely unique and separate from each other in the way in which this revolution happened. But it happened fairly simultaneously between all 3 regions: the Fertile Crescent, Central America, and Eastern Asia. Farming. Humans learned by accident how to farm and how to domesticate livestock around 9 or 10,000 years ago. This led to the first population boom because it allowed for cities and settlements and towns to form because humans were no longer nomadic, no longer hunter-gatherers, and so once humans accidentally learned to farm, this allowed for the rise of cities and settlements and ultimately other sort of jobs, like we would consider jobs like educators or writers or philosophers or et cetera, et cetera, et cetera, right? So this allowed for one of the first population expansions of humans. The second major population expansion happened about 200 or 300 years ago, which accelerated with the industrial and then the medical revolution. Okay, so that you can see for many years the population of humans remained below 1 billion, and then about 1850, 1900 or so, the population exploded, and we're now approaching 8 billion people on the planet. My dog is walking around here, very nosy. There he is in the background. Here's another way of looking at that. You can see that there's a sort of semi-nomadic era with the advent of early agriculture, then the rise of city-states around 4,000 or 5,000 years ago, which allowed for this population to grow, the population of humans to grow. Then we have the era of empires, and then finally the global era, which coincided with the Industrial Revolution and also the medical revolution, right? Penicillin, antibiotics, our ability to treat things, diseases, etc., allowing us to live longer. This scale here is logarithmic, exponential, which means that it goes from 1 million to 4 million to 10 million to 1,000 million, which is a billion, 2 billion, 7 billion. So it's been sort of compacted and shrunk at the top to give an idea of what this exponential growth looks like. So we often use logarithmic scales like this to show things like this. So it's showing basically the same thing as this figure, but kind of more stretched out so you can kind of see what the ups and downs look like. Now, all those people are not evenly distributed across the globe, of course, right? There are lots of people living in cities, not a lot of people living in the Sahara Desert or the Arctic Circle. So this map here shows the population density of humans across the globe. The dark red, or the darker the red and orange colors, the more people there are living per square mile or per square meter, or however you want to think about it, right? So in the US, for example, you can very clearly see where the big cities are. So I can see Chicago, for example. I can see the eastern coast. I can see Los Angeles and the San Francisco Bay Area, Seattle, Portland, right? When I get over to Europe, Western Europe, or India, or China, or even Africa, the cities become, I think, less apparent. You know that, and also there's more people living there per square area. So the population density of, for example, the Ganges River Valley in northern India here, or eastern, of course, China and the Korean Peninsula and Japan, very heavily populated, high population density. People are increasingly moving to cities. So densely populated areas are getting even more populated, even more dense. So a good example of this, right, is Mexico City, which in 1955 had a population of under 4 million people, and by 2015 had a population of 22 million almost people. And so you can see the size of that dot for Mexico City grew substantially. Even Tokyo, an already big city in 1955 with over 13.5 million people, by 2015 is approaching 36 million people. New York, even a slower growth, still growing since 1955. Buenos Aires, Sao Paulo, Lagos, all of these cities are seeing incredible explosions in population since the 50s, coinciding with what we might what we often term the Great Acceleration or the Anthropocene, which is what we're kind of talking about today. So all of those humans living in cities and scattered across the globe have a large and enormously undue influence on the Earth, right? So we can look at this figure here, which shows the Human Influence Index. The lighter blue is a low influence. The darker red is a high influence. So you can see, obviously, in cities or in more densely populated areas, there's a large influence of people on the Earth system, on the Earth's surface. Less so where there are less people. However, you'll notice that there are far-reaching impacts of humans well outside of these major metropolitan areas. One area that sticks out to me is up here, sort of the northern Great Plains into southern Canada, also over here in Eastern Europe into Russia and the former USSR, Soviet states. These places are relatively sparsely populated, and yet you see that there is a very large swath of area where there is a low to medium influence by humans on the Earth's system. So normally in class I would ask you what you think is causing that influence, but I'm just going to tell you the answer, and the answer is, of course, farming. So farming is the revolution that kind of changed the way that humans live on the globe. Farming is one of the most critical concerns of the Anthropocene, specifically animal agriculture and high-intensity cropland farming, right? Corn, soy, rice, wheat, for example, and other crops, cereal crops, are especially exert an especially large influence on the Earth's surface. And so you can see that swath that I was noting on the previous figure up here, right, is a very intense swath of high cropland intensity, a very large swath of high cropland intensity. There's a lot of crops being grown there. Corn, wheat, soy are the main ones. And over here in Eastern Europe and into the former Soviet states and Russia, also high cropland intensity. Same in the Ganges River Valley, throughout sub-Saharan Africa and South America, Eastern Asia, and of course Southern Australia. So lots of land on the planet is taken up and used by farming, both through croplands, which we might consider as places where we grow things for our direct consumption, and also through pasture grazing, which is where we would domesticate, where we keep our domesticated livestock, pigs, cattle, chickens, etc. Okay, and often those pastures overlap with the regions where there is high cropland intensity. Of course, all of this farming, specifically all of the cropland farming, is really doing a number on the soil and the status of the soil across the globe. So much of the soil on Earth in 2020 is degraded due to human farming, due to anthropogenic influences, due to farming. So you can see North America has degraded or very degraded soil pretty much across the whole United States. We've been very intensely farming this region for many years, and that has led to a decrease in the fertility and the ability for the soil to supply its own nutrients to the crops that are being grown. Same with much of the globe, actually, much of Africa, much of Europe and Asia and South America. So anywhere there's red and orange is like degraded or very degraded soil. So with all of this farming across the planet, number one sort of factor in considering the anthroposphere, right, is farming, and the soil degradation being sort of one of the first major negative impacts of all of this farming. What do you think the human solution to all of this degraded soil is? Well, of course, the human solution is to dump fertilizer on top of the soil, which we do quite frequently here in the United States and across the globe. And of course, all of this fertilizer contains nitrogen. Nitrogen is a really important nutrient for crops. And as that nitrogen decomposes in the soil, right, and as it, well, first it goes into the soil and then it's taken up by the plants, and as those plants die or some roots die or various things happen through the natural processes of things, some of that nitrogen becomes N2O, nitrous oxide, which is a greenhouse gas. And of course, greenhouse gases are a real problem, as we talked about last week, and we'll continue to talk about moving forward in this class. So our nitrogen fertilizer on top of our degraded soil is inadvertently contributing to climate change in a different way than carbon dioxide emissions do, but important nonetheless. All of this cropland has also led to a lot of forest loss. So much of the forested land across the globe has been removed and replaced by either croplands or, of course, cities and settlements. Some of it is being deliberately destroyed even still today, like, for example, in the Amazon, in the Congo, and in equatorial Asia, or Indonesia and Malaysia, and Borneo and Sumatra, the islands of Borneo and Sumatra, etc. Across the United States and Europe, a lot of this forest was lost many years ago, 100, 200 years ago, as population expanded in the industrial and medical revolutions. And so you can see that there's some forest loss here showing up on this figure. So anyway, the intact forests are in green, and the lost forests are, of course, in red. And so you can see much of the virgin native ancient forests in Europe are lost by farming and by human settlement. And across the United States, a lot of the forest, especially towards the Midwest, has been lost. But on the East Coast, you'll notice there's a swath of green here. A lot of those forests actually were originally leveled and torn down and have since regrown. So a lot of the forests on the East Coast, if you've been to the East Coast, it's a very forested region, but a lot of those forests are actually only 100, 120 years old or so. And this figure shows that. This figure shows where the net gain has been, and that's a lot of along the East Coast of that forest, is regrowth in the last 50 to 100 years. Now, one of the places where forest loss is kind of the most infamous and poses an enormous problem for the globe is the Amazon. The Amazon is often considered the lungs of the earth. It produces a lot of the oxygen that we breathe. Now, don't worry, all of that forest that has been lost and continues to be lost doesn't mean that we're going to run out of oxygen, but it does mean that the ecology and the climate of the planet are changing and will change due to much less forest at the equator. So on the left here on this figure, we can see what the original forest cover of Brazil and the Amazon looked like. Anywhere there's green is very high, untouched, undisturbed, ancient virgin forest. And then on the right, you can see that the areas of dark green have significantly diminished. Up here in the north, this is the Amazon, and you can see that human deforestation is spreading into this region from mainly the south and the west. Much of the forest in southern Brazil is gone and probably is not going to come back. Not necessarily part of the Amazon, but nonetheless an important story. But focusing on the Amazon, you can see the Amazon here largely intact 150 years ago or so, and then now just really starting to thin out and decimate because of human deforestation efforts from the west and the south coming in, sort of encroaching on the Amazon. One other sort of important part of the biosphere, and by extension, as you'll see here, the anthroposphere, are these biodiversity hotspots. So humans really rely on nature, on our forests, on our grasslands, of course, for lots of things. We obviously rely on our grasslands and savannas for farming. As I've mentioned, we've torn down some forests for farming, but we also rely on these biodiversity hotspots, because they're places where there are plants indigenous to those regions that do not grow anywhere else, and there's a lot of them. There's a lot of variety. There's a lot of diversity. So one of these places, of course, is California. California is a very biodiverse region. There are like hundreds of different species of plants and animals, more than that really, but I think there are like dozens of different species just of sage, just different types of sage bushes and grasses and stuff. So there's lots of biodiversity in California. There's a lot of biodiversity in Central America and equatorial Asia. Two rainforests that are really threatened by human activity, really threatened by encroachment by settlements and farming, right? So here from Mexico down through Panama, and then over here on the Malaysian Peninsula and Borneo and Sumatra and Java and Papua New Guinea, etc. Also the Horn of Africa here, adjacent to the Great Rift Valley, where modern anatomical humans actually first evolved, first stood up on 2 feet. Also a biodiverse hotspot. So and of course the Mediterranean, very biodiverse. Lots of diversity, meaning there's a lot of different species. There's a high number of unique species that do not grow anywhere else. These biodiverse hotspots, like everything else, in the anthroposphere is threatened by human activity, by farming, by settlement, by climate change, and by our overuse of the resources that we get from these biodiversity hotspots. So we get lots of things from these places that contribute to our everyday life: medicine, food, materials for building, and other things, right? So these biodiverse hotspots are really, really important. And if we flip to the next slide here and we look at where regions of the globe are protected by government decree, so national parks or parkland or protected areas, you can see that there are a fair amount of them. I think 30% of all the land, or 10, I can't remember the exact number, 10 to 30%, somewhere in that range, of all the land on Earth is protected by the government, by various governments. That doesn't mean it's impervious and there's nothing bad going on in those areas, but they are ostensibly protected by law. But you can see that they don't really overlap with the biodiversity hotspots. They don't really overlap with the biodiversity hotspots or other things that we might think that they maybe should for human survival. Instead, a lot of these protected areas are protected because they are pretty. So they're aesthetic. Also, they sometimes serve as habitats for endangered species, which we'll talk about in the Zoom tomorrow, the whole issue with endangered species. Please, someone ask me that question, because I will. I have a lot to say about that. So protected areas are not often protected because they're particularly useful for us, or to our survival, but because we think they're pretty, or because they are the habitats of a number of species that we've deemed endangered. So protected areas are great. I think it's really important that we have the Grand Canyon. It's really important that we have these various protected areas to preserve some of sort of what we would maybe consider virgin nature or untouched, undisturbed natural environments. But of course, there's a lot of thought hasn't gone into these protected areas as areas that might be beneficial to human survival. And there's a debate with that, and we can absolutely have that conversation. So on the theme of biodiversity, then, continuing sort of with the map theme here, this map shows regions where the threat to biodiversity due to human influence is high. That's in the yellow and the red. So the yellow and the red areas are where the threat to biodiversity is high. And you can see that includes California, that includes parts of the Horn of Africa, Eastern Asia, the Indonesian rainforest, parts of Central America. There is an enormous threat to biodiversity around the globe, which is going to be a difficult challenge for us in the next 100 years, right? And that's not even necessarily all because of climate change, although a good portion of that is due to the changing climate, as we'll talk about. But on top of the threats to biodiversity, there are also important challenges around the availability of water, drinking water, irrigation water, right? A lot of the crops that we grow to feed over 7 billion people need water to be artificially brought in so that they can grow. They grow in areas that maybe don't receive regular rain, but have very rich soil or have available soil or available land. And as the climate changes, right, as the climate changes and as human distribution across the globe changes, and where our farms are, where our cities are, this presents an enormous threat to the availability of water. So anywhere on this map that's red or brown are regions where there's a large, high threat to water availability, or water scarcity is forecast to be, there's forecast to be a lot of water scarcity in these regions in the coming decades due to the undue influence of humans. So you can see that much of the globe is faced with threats to biodiversity or water scarcity. And much of these regions are very heavily populated, like, for example, Eastern Asia and India and the whole United States. Really, the biodiversity is threatened due to all of the things that we do, our fertilizer, our farming, our population density, our cities, our suburbs, our everything. Same everywhere, really. Europe is very similar. There is, I will note, the Sahel and Eastern Africa regions. So the Sahel is up here, Eastern Africa here. These are facing lots of challenges in the coming decades due to water scarcity and biodiversity. And these are really economically fragile, geopolitically fragile regions, which are sort of forced to face the worst effects of climate change, unfortunately. And so this is something that we do need to consider and keep in mind. Now, of course, all of this food, all of this water, all of this stuff is being consumed by humans, and so that's also not necessarily distributed equally. So this map here shows where the human consumption is occurring, right? The darker browns are where there are where there's a lot of calories and carbon being consumed through eating or through making things or even through producing waste. In this first plot here, it tracks fairly well with population density, but as you'll see in the next slide, it doesn't track one-to-one. There's not a perfect ratio between population density and human consumption of resources. Also, I think an interesting figure is this one. It's very difficult to sort of see, but this shows the percentage of human consumption divided by, or the amount of human consumption divided by how many resources are actually produced per sort of geographical region, per square mile, for example, right? So where it's pink, that's where tons of calories or resources are consumed and very little are produced. And so that's mainly the cities and other regions. And then, of course, you've got areas where it's much less than that, right? Less than 100%, where you're doing all of the farming, you're doing all the resource extraction and things, and then those are being shipped to the cities. So cities themselves sit on land that's relatively unproductive because we've paved it over with asphalt, we've done all these various things. So we export a lot of our resource extraction to the farms, to areas that are far away from us. We don't see our crops being grown. We don't see our animals being grazed or slaughtered. We don't see our resources being extracted from virgin forests, right? Because we're in cities. We don't see that. We just consume it. So this consumption of resources and the divorcement from these areas where the resources are actually being produced and grown is a problem. And I mentioned that it's not equal everywhere. So places like the US and Canada and Western Europe consume way more calories per person than for example, Central Africa or South America, where you can see that the number of calories being consumed per person is significantly less, right? So even though even though it sort of tracks with population density, there are some countries and some regions that are just a lot greedier of these limited resources that the Earth has to offer. Here's another map which is kind of redundant. I just really want to hammer home the point that one of the most important challenges that we face within the anthroposphere and moving forward with climate change and with the Anthropocene is farming, is global food production, is agriculture, especially animal agriculture. So this map just shows regions where the cropland is more than 90% or the grazing land is more than 90% or both. There's a mosaic, right? So I mentioned that they do kind of overlap. But there are some regions where there's mostly grazing land, and there are some regions where there is mostly cropland. Of course, the farming and extraction of resources from biodiverse hotspots are not the only resources that we're extracting from our Earth. We also extract fossil fuels, which we then pump into the atmosphere. Something happened there where like the fucking QuickTime froze again, per usual. As I was saying, one of the resources that we extract very heavily from our planet, of course, is fossil fuels, and then we burn them for energy generation, and then their waste products end up in our atmosphere where they are causing climate change. So here's a map of all the oil fields, for example, and the pipelines connecting them in Saudi Arabia. Here's where all the oil is left across the country. Across the world. Sorry, something like 20 countries control like 95% or more of the world's oil. So this level of extraction is very widespread and has been going on for a really long time. There's also new methods of extraction, for example, shale oil fields. So people aren't giving up. Even if we run out of oil, people are not giving up. There's also a lot of coal deposits across the globe. So coal is kind of a dying industry as well, but you can see there's quite a bit of anthracite and bituminous and lignite coal in the various colors here. The US, Russia, China, and Australia are the biggest producers of coal across the planet. Of course, the Industrial Revolution began with the extraction and burning of coal for generating power for the steam engine in the United Kingdom, which you can see here has very small little teeny coal deposits. The thing that I want you to remember is that we will not run out of fossil fuels. This map here shows the amount of fuel that we've used is in the purple to date. The amount that we've got in reserve is in the blue, and the amount that we think that we can recover to reuse is in the yellow. And you can see that for conventional methods, we still have quite a bit of oil on reserve or recoverables, quite a bit of gas, quite a bit of coal. And if you switch to unconventional methods, namely fracking or shale oil, you've got a ton of available resources still in the ground, still for use. Something like 50 to 150 or more years worth left of these various fossil fuels. I want to end on a slightly optimistic note because I think sometimes this Anthropocene can get really depressing. So I will say that there is another way. We can live on this planet responsibly and sustainably, and we can stop extracting fossil fuels, creating climate change, because there's quite a bit of renewable energy out there. This map shows where all the available wind energy is located, right? So the reds and the orange is where it's the windiest, which means that's where you're going to get the most energy generation. So definitely along almost all the coastlines, but especially at the further north and south you go from the equator. Also, I will just point out the central United States, where there are quite a bit of windmills already going up, windmill farms. There is a huge potential for supplying an enormous amount of energy and power from generation from winds. There's also geothermal energy potential, where the plates are colliding, where there are earthquakes and other tectonic type activities. And so you can see along the west coast, for example, in the Great Rift Valley of Africa and the Mediterranean, and all throughout Indonesia and Equatorial Asia, there's quite significant potential from geothermal energy. There's also a lot of potential for energy extraction from the sun, from solar energy. And you'll notice that this, of course, is concentrated closer to the equator, which is a little different than the wind energy map, which is further to the pole. So there is something for everyone here. There's sun, there's geothermal, there's wind, there's wave energy, right? If you live along the coastline, especially if you're in Northern Europe, maybe where there's not a lot of sun, but there's a lot of wave activity. The Horn of Africa and South America have the potential for generation of energy from waves. So there's a lot of potential solutions to this, and so we're going to continue this conversation, but that's kind of just a little introduction to what is the Anthropocene, what is the Anthroposphere, how is it an integral part of the Anthropocene. In class tomorrow, we'll have a smaller lecture just on the Great Acceleration, which we'll talk about, which is a really important component of the Anthropocene, but it's difficult to I never know where to sort of include it, so we'll do that live in class and probably record that for folks who can't make the Zoom tomorrow. All right, so with that is the end of this lecture. Um,